Okay. Oh, the C class gave me a joke yesterday. Do you guys want to hear the joke?
Yes.
Yes.
Okay.
Yes.
So it's from Rita. She did a presentation on Saturn. Now, you know that Saturn has beautiful rings around it, right? So on Saturday, God created Saturn, and he liked it so much that he gave it a ring. That's a joke.
You put a ring on.
He put a ring on it. Yes, he put a ring on it. Like asking Saturn for marriage.
Did
Okay.
Saturn accept?
Saturn has no choice, I guess. Okay, Win, go for it.
Okay, wait. Let me present.
Okay, everybody,
Let's
follow
see.
along with Win. And I want Che to ask Win questions after this, okay?
Where do you see it?
Hold on. Yes, I see your slide. It's a beautiful slide.
Okay.
Okay, anytime you're ready.
So the sun has 7 layers. The outer one is called corona, and then there's the chromosphere, the photosphere, the subsurface flow, the convection zone, and the radiative zone, and the inside is made out of the inner core. It's really hot. It's about the inside, the inner core is about 15 million Celsius hot. So, out of our solar system, the sun accounts for 99.86% of the mass, and the sun is over 1 million times Earth's size. One day, the sun will consume the Earth because its hydrogen will all burn off. And once it consumes the Earth, one day it will be as small as the Earth. The sun is also almost a perfect sphere. If it was 10 kilometers wider, it would be a perfect sphere. And it is currently traveling at 220 kilometers per second. It also has really fast solar winds, which are traveling at 350 kilometers per second. And the solar winds are so hot, if you even touch them for 1 second, all your bones will burn off and you will die. So in the morning, it takes 8 minutes for the light from the sun to reach Earth. And in about 5 billion years, the sun will explode. Okay, I'm done.
Okay, interesting. All right, Che, ask him some questions.
How far is the sun from Earth?
Huh? Can you repeat it?
How far is the sun from Earth?
150.7 million kilometers.
Okay.
What is that in astronomical unit, the AU?
Yes. In Australian units.
I don't know.
How many AUs is the sun from the Earth?
Australian units.
It's not Australian,
One.
it's astronomical unit.
Uh-huh.
Yeah, it's exactly 1 AU. 1 AU. So that's very convenient unit. 1 AU. And then to Mars is like 1.3 or something, 1.5. And then Jupiter, 4 AUs or something like that, 5 AUs. Okay, let me bring it up real quick so I can go through this with you guys. Okay, so distance to planets in AU, in astronomical unit. Okay, So now Mercury. Mercury, is that less than 1 AU or more than 1 AU? Win?
Hmm?
Mercury. Is that less than 1 AU or more than 1 AU from the
I
sun?
think less.
Less. So Mercury is 0.4. 0.4 AU. Venus is 0.7. Earth is 1 exactly. Mars is 1.5. Okay, I was close. 1.5. And what else? Mars is 1.5. The next one, Jupiter. Jupiter is 5. So it jumped. Now, Win, do you know why it jumped from 1.5 to 5? So Mars is 1.5 and Jupiter is 5 AU.
It's because it's far.
Yeah,
Far.
because Jupiter is part of what? Inner or outer?
Outer.
Outer, right? Jupiter is part of outer planets, so that's why it's far. So the inner planets are very close. Okay, so the inner planets go from 0.4 to 1.5 AUs from the sun. And the outer planets go from 5.2, that's Jupiter, all the way to Neptune, which is 30. 5.2 to 30. Oh my God. So 30 times further from the sun is Neptune compared to Earth. Uranus or Uranus, doesn't matter how you want to pronounce it. I think Mohan prefers Uranus. Okay. 19 AU. 19 AU. All right. Any other questions for Win on the sun?
No.
Okay.
Okay.
Now, look at the corona. Does that corona have anything to do with coronavirus?
No.
No? Okay, so different corona. All right.
Okay.
So, Win, I have one last
How about
question, Win. One last question. So, you learned about electromagnetic spectrum, right? Remember we
Yeah.
did a quiz on it? Okay. So, what waves are in the electromagnetic spectrum? What waves? You remember, Win?
Some. Yeah, I remember some.
Tell me some.
There's gamma ray, X-ray, and there's radio, microwave. There's UV.
Okay. All right. Good job. Good job. Which one? Which of those waves come from the sun?
Mm. Uh.
Come on, Win.
Ultraviolet.
You're the smartest person in the class.
Is it UV, Mr.
There's
Rashad?
UV and visible and infrared.
The answer
There's
is
UV.
is
It is
everything.
UV.
Everything. All those waves come from the sun. Okay, all those waves. That's how we know. That's how we can measure it. Okay, that's how we know that gamma ray exists, because the sun will shoot us bursts of gamma rays. Without atmosphere, we'll all be dead. Okay, so
Okay.
everything, all those rays come from the sun. Now, are there more rays that we don't know about? Maybe. Okay, maybe in like very far away part of the universe, because we only see so much. We only see what's inside our galaxy, you know, most of the time. So we don't get anything from very far away places, but we keep listening, or we keep detecting them. That's why we have big satellite dishes. Okay.
Okay.
All right. Good job, Win.
Okay.
So Che, you next.
Okay. Wait, I present my screen, yeah?
Yes.
Okay. Can you see my screen?
It's coming up.
Okay.
Takes a few seconds.
Okay.
Hold on, not yet. Okay, I can see the slide now. The Oort Cloud.
Yes.
Okay.
Hold up. Okay. Okay. So today I will be presenting about the Oort cloud. Wait, can you hear me?
Yes.
Okay. The Oort cloud was named after the Dutch astronomer named Jan Oort. That's why it's called the Oort cloud. And the Oort cloud is 100,000 astronomical units away from Earth, which is 1.49598 E plus 13 kilometers away from Earth, which is a lot.
Yeah. 13
And
zeros.
yes, and the Oort cloud was discovered in 1950. And Voyager 1, the fastest and furthest of the interplanetary space probes currently leaving the solar system, will reach the Oort cloud in about 300 years and would take about 30,000 years to pass through it, according to Google.
30,000 years. Wow.
Yes. What is it made of? It is mostly composed of water ice, ammonia, and methane, whatever that is. How old is the Oort cloud? It is 4.6 billion years old. And this is the Oort cloud where I'm pointing at with the red thingy.
Okay.
And this is the Earth. And this is about 100,000 AU.
100,000 AU.
And Oort cloud, yes,
Wow.
very far. And this is how it looks like.
So 100,000 is at the furthest edge of the Oort cloud, okay? Not the nearest edge, at the outer edge. So
Yes.
that's 10 to the fifth. 10 to the fifth is 1 and then 5 zeros after the 1. So that's 100,000.
Yes. So this to this is 100,000.
Yeah. So it's pretty long or thick, pretty thick shield bubble.
Thick.
Yeah, it's a thick bubble.
Yes. It's like a cloud.
I see.
Okay, I'm done.
Okay. All right. So the last presenter, Win, will have to ask questions.
Okay, how big is it?
It is around, I don't know.
So you take the nearest part. The nearest part is what? 10 to the third. And then the farthest part is 10 to the fifth, and you subtract them.
So it is 10 to the,
No, 100,000 minus 1,000.
oh,
Right? So 10 to the fifth is 100,000. 10 to the fourth is 10,000. 10 to the third is 1,000. Okay. So you take 10 to the fifth minus 10 to the third. So 100,000 minus 1,000 is how much?
99,000.
99,000. That's it. So
Yes.
99. Okay.
Okay.
But make it 95, something like that. 95,000. Is that in kilometers?
No, it's AU.
Oh, AU. Oh, 95,000 AU. Wow. That is very thick cloud. Very thick cloud.
Yes.
Okay. Now, I think I told you guys this already. When you see clouds in the sky, and many of you have seen clouds for the last few days, right? Because it has been raining. Okay. How thick do you think the clouds are in the sky?
Not that thick.
Give me a number. From
Uh,
the bottom of the clouds that you can see to the top of the clouds that you cannot see.
2 kilometers.
How many?
2 kilometers.
2 kilometers. Any other guesses? Okay, well, it can be as thick as 11 kilometers from the bottom to the top of the clouds. Okay, like 10 kilometers, 9 kilometers, easy. Okay, so it's you only see the bottom of it. You don't see how much water vapor up there. You know, a lot of water evaporate every day from the oceans, from the trees. Like a big tree can evaporate many gallons of water per day. Many gallons.
Yes.
Yeah, 1 gallon is 4 liters. So many liters.
Mr.
Okay.
Roshan, is ammonia and methane.
Okay, ammonia. You know ammonia. Ammonia is very common in Thailand. Do you know when somebody faints, when somebody pass out, and you see a nurse trying to get that person to smell something?
Oh.
That's ammonia, right?
Not
So
good.
I'm sure many of you have smelled it. So it's a pungent, very strong smell. So to wake them up. Okay, ammonia. So when somebody is passing out, like they stand in the sun for too long, like students standing in the sun and passing out, and then you let them smell ammonia and they wake up because it's very strong. Okay. Now methane gas. Okay. If you want to know the chemical formula, like Perry likes chemistry, right? Okay. And Pan, I think you guys like chemistry. Okay. Ammonia is NH3. N is nitrogen, H is hydrogen. So NH3. Okay, that's ammonia. Okay, methane.
Is there methane in fart?
Yes, 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 you're right. So it smells like fart. Okay. Now, Che, do you know what biofuel is? Biomass. You know what biomass is?
Yeah.
Okay. So the droppings that come from the animals, right?
Yeah.
So did you know that we can turn those droppings into fuel?
Oh.
Yeah.
Cool.
So if you have a lot of cow poop, okay, a lot of animal waste, you can collect them together and then you can ferment them, and then it will give off the gas.
Bio.
And a lot of that gas is methane. Okay, methane is CH4, carbon and and 4 hydrogen atoms. Okay, okay. Let me double check to see if my chemistry is, if I still remember it correctly. Methane chemical formula. I think it's CH4. It is CH4. Okay. CH4 is the simplest one, and it's very flammable. It catches on fire easily. So you can use it as fuel. Okay. But if you breathe too much methane, you dead.
You die.
You die.
Yes.
A little is
You go
okay.
bye-bye.
So if you full of a room of Mohans, and all these Mohans start farting, and you keep smelling it, you're gonna die.
So mean, Mr. Roshan.
Okay, okay. Mohan, you never do that. I know you never do that in front of your friends. Okay. So if you breathe too much methane gas, you're dead. You die. That's why you need uh, what does the astronaut put on before they go outside? Okay.
Spacesuit.
Spacesuit. Yeah. You need a spacesuit. Otherwise you cannot breathe. Okay. Any more questions for the Oort Cloud? That is on your test, by the way. Okay, no more questions. Good job, Che.
Yeah.
Okay, next person. Go ahead. Who's next?
Hello?
Yes. Okay, Pat. Yeah, I saw your video. Pretty good.
Can you present it for
Yeah, go ahead and play it for us. Make sure the volume is on the maximum. Okay, it's coming up, Pat.
Can you guys see anything or no?
I saw your slide and then you took it away.
For this one. Can you see now?
Yes, I see the slide now.
Can
I don't hear anything.
I already played the sound man.
Can anybody help Pat?
I think I have the problem with Perry.
Same problem with Perry?
Yeah.
So how did Perry fix it?
I looked at the video on my phone. I turned the volume to max and I put it near the
Oh,
iPad that I'm presenting on.
okay. All right.
Good.
Hey, Pat, did you email that to me?
I send you in line.
You sent it in line.
I can email it.
Can you email it to me? I will present it for everybody then. Okay. Okay, so Pat is going to email it to me and then I'll present it. All right, we're going to go to the next person to save time. Okay. Kelly, you next. Go for it. Kelly. Kelly Pawarisa. Are you with us, Kelly? Or are you still doing your yoga?
Yes, I'm with you, but lag. My computer is lag, so I have to join with my iPad.
Okay.
Oh, wait.
So Pat will be after Kelly, I mean. Okay, I see something. I see a slide.
Can you hear it?
I can hear you, but I cannot hear the slide. Turn on maximum volume.
Mr. Wachan, I sent to you already.
Okay. I got it. Kelly, we cannot hear anything, Kelly. Kelly, we still cannot hear anything.
Can you hear it?
No. Oh, hey, Kelly, I have an idea.
Can you hear me, Mr. Rashan?
I can hear you right now. So Kelly, just do this. Just present your slide. I have
Can you
your
hear me?
audio. I can hear you.
Okay.
So how about you do this? You just show me the slide and then I will play your audio. I have your audio.
Okay, wait.
You want me to do that?
Wait. Let me try it again.
Okay. Is it playing? No sound. No sound.
What? Have no sound?
No sound.
Okay, then Mr. Rashan, you turn on the.
Okay. So I'm gonna turn on the your audio. You just show the slide. Just show the slide right now.
Okay, wait.
Okay, good. All right. Now you let me know if you can hear this.
Information about Pluto. The diameter of Pluto is
Can you hear that?
2,372 kilometers.
Okay. Let me restart it.
So I will be presenting about Pluto. So here's the basic information about Pluto. The diameter of Pluto is 2,372 kilometers, and the mass is 1.31 times 10 power to 20 power of 22 kilograms, which is 0.17 moons. The surface temperature is minus 229 degrees Celsius. Orbiting distance is 5,874,000,000. Orbiting period is 248.0 years. And the moon is 5, Charon. Discovered date is in 18 February 1930. And it was discovered by Clyde Tombaugh. Category is dwarf planet. And the composition of Pluto is 60% of rocks, 40% of frozen gases. Fantastic facts. Pluto is the biggest dwarf planet out of all of the 5 others. Pluto was considered a planet in 2006, but has been debated also not to be a planet. But it was also specified as dwarf planet the same year. Ganymede, Titan, Callisto, Io, Europa, Triton, and the Earth's moon. These moons are bigger than Pluto. Astronomical changed Pluto, downgraded the status of Pluto to draft planet because it did not meet the three criteria the IAL uses to define a full-size planet. Thank you.
Okay. So the last presenter was Che. So Che, ask her some questions about Pluto. Kelly, don't take away the slide.
Okay. Can you see it?
Yeah.
Okay.
Questions about Pluto, please.
How far is Pluto from the Earth?
Huh?
How far is Pluto from Earth in AU?
What the hell? Okay. It's 5.048 billion kilometers.
Okay.
It's AU. He's asking how far is it in AU, not kilometers.
In AU, it's I don't know in AU.
Yes, you do. It's on your slide.
Oh, wait, where? It's 28 AU.
28. Where did you get that? Okay, seems like Kelly. All right, you put on your slide orbiting distance. Orbiting distance. Tell me what that means. What does orbit mean? Orbit.
Orbit is like you go around the sun.
Going around the sun. Okay, so that's the distance. The distance from where to where? From what to what?
From the Pluto to the sun.
Okay, so from Pluto to the sun is how many AUs?
39.26.
Okay, so 39 AUs from Pluto to the sun. Now, Che just asked you from the Earth to Pluto. Okay, now from Earth to the sun is how many AU from the Earth to the sun?
50 AU.
What? Okay, hold on. One at a time. From the Earth to the sun is how many AU?
From the Earth to the sun is 1 AU.
Is 1 AU. From Earth to sun is 1 AU. Okay, from Pluto to the sun is 39 AU. So what is it from the Pluto to the Earth?
38.
38. You got it. You got it. So that's Che's question. I don't even know if Che knows is 38 AU. Okay, but it's a good question. All right. I'll give you benefit of the doubt. Okay. Other questions for Kelly? I think Perry has a question for you. Perry likes to ask these things. Mickey, you have a question for Kelly? Come on, she likes it when people ask her questions.
No.
Nian?
What's the most common dwarf planet in the universe?
What? It's probably Pluto, I think.
I'm just kidding.
There is a lot of dwarf planets out there. A lot of dwarf planets. We have many in our solar system. Okay, Pluto is not the only one. Okay,
Yeah.
so
But it's the biggest. Pluto is the biggest.
Pluto. Okay, how many dwarf planets? Take a guess, guys. How many dwarf planets in our solar system?
Millions.
5.
5. Very good. Very good. 5. Good job, Nian. Yeah, 5 dwarf planets, and Pluto is the biggest one. All right.
It said in the slide.
It does?
Yeah, it said Pluto is the biggest dwarf planet out of the 5 others.
Okay, 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 good, good. All right. Okay, what's the main reason? I have a question for Kelly. Tell me the main reason that the astronomers took Pluto out of the planet category. It's not too small. No, it's not the size.
What?
Why that we change it from the ninth planet to a dwarf, to a dwarf planet? Anybody?
Wait, let me think.
Okay.
I don't know.
Okay. All right. I'll tell you the answer, and the whole class needs to know this. Okay. To become a planet, you must have your own orbit. You cannot share your orbit with another planet, or like a moon, or any big size objects. Okay. Any big objects, you cannot share your orbit with those objects. So you must have your own orbit. At the beginning of the solar system, so all these rocks are flying around the sun, okay? And soon these rocks combine with other rocks and become planet like the Earth. So the Earth has its own path, has its own orbit, because it already collected all the dirt, all the debris in its path, in its orbit, and it becomes its own object. There's only one object in that orbit, one big object. We don't count the small little objects, okay? So the small dust and space rocks, we don't count. Only big objects, okay? So Pluto hasn't cleared its path yet. So to become a planet, you have to have a clear path, and don't share that path with any other big objects, okay? So that's the main reason. And the secondary reason is Pluto is not in the same plane as all the other planets. Kelly, you understand that? The same plane, the orbital plane?
Yeah.
Yeah. It's like all the other planets.
Taking further north and
Say
south.
again?
It's taking further north and south of the Earth.
Yes, yes. Also, okay, Kelly, do you like a pizza?
Yeah.
Okay. Now imagine at the center of the pizza is the sun, and around the pizza is the 8 planets. Okay, and all the 8 planets, they stay within the pizza. They go around within the pizza. But Pluto doesn't stay inside the pizza. It goes around the sun, but it goes outside the pizza. You understand?
Yes.
So that's why we say it's not in the same plane as the other planets. Okay? All right. Any other questions for Kelly and Pluto? Many people, Pluto is many people's favorite planet. Okay, many kids like Pluto, but then we declassify it. Sunyan said something. Criteria defines food size. It has not clear neighboring regions of other objects. Yeah, it has not clear its own path. Its own path. Okay. All right.
Mr. Rachan, wait, Mr. Rachan, in Google it says that Pluto is the second biggest dwarf planet.
No, it's the biggest.
With Iris being the most massive known dwarf planet.
We're just talking about solar system here, right?
Oh, Iris is out of the... Right. Oh yeah, in the diagram, Iris is out of the Kuiper belt.
It's the largest known dwarf planet in the solar system.
Oh.
Okay. All right. So I'm gonna play Pat's video. So you can stop presenting.
Saturn is the sixth planet from the Sun.
Okay. All right, let me share my screen. So you guys let me know if you can hear it, okay? So this is Pat's presentation. It's pretty good. I watched it 2 times already. Okay.
Saturn is the sixth planet from the Sun and
Can you guys hear that? Yes?
Yes.
Okay. All right. One more time.
Saturn is the sixth planet from the Sun and the second largest planet in our solar system, and is formed 4.5 billion years ago. Saturn is surrounded with a beautiful ring which makes it unique. The ring is made out of chunks of ice and rock. Saturn is not solid like Earth, but instead is a giant gas planet. It is a giant ball of hydrogen, helium, methane, and water ice. Saturn's atmosphere is one of the windiest places in the solar system, with the wind speed of 1,800 km per hour. Saturn has 62 moons, and the largest moon is Titan, the second largest moon in the solar system, but most of it is tiny. Saturn has a relationship with its moon and gravity. Titan has tides, and some of the smaller moons orbit within the Saturn ring to help stabilize them, similar to how the moon helps to stabilize the Earth. Saturn is the sixth planet from the Sun and the...
Oh, okay. Repeats. All right. Good job. The last presenter, Kelly. So Kelly, you're going to ask him some questions about Saturn.
Okay, so what color are Saturn's rings? Can you hear me?
I can hear you.
Yeah.
What color is Saturn's rings?
Yeah, good question. So, Pat, you better start Googling.
It's a little bit of brown, pink, and gray.
Brown, pink, and gray. Okay.
Okay.
Now, the next question is, what makes up the rings? Is it just rocks or gas?
No, it's the rocks and the ice.
Okay. Rocks and space rocks and ice. Okay. Good. Good. All right. Any other questions for Saturn? The most beautiful planet in the solar system. Nikki, come on. Ask him some questions.
I got one.
Okay, Richie, go for it.
What's the distance from the sun to Saturn?
What's the distance?
It's about 1.4963 billion kilometer.
Okay. 1.4. Okay. Million kilometers. 1.4 million. Is it million kilometers?
Billion.
Billion kilometers. Okay. All right. Good. So that's about how many AUs? Let me see. I still have that up. Okay, so Saturn is about 9.5.
9.
Yeah, 9. 9 AUs. So 9 times further than the Earth from the sun. Now the gravity, look at the gravity of Saturn. What is the gravity of Earth, Pat?
10 or 9.
Okay.
9 and 10.
So what's the gravity on Saturn?
About 10.44.
Okay. So about the same, right? About the same as the Earth. So
yeah.
So that you can jump about the same distance on Saturn. So when you play basketball, you jump about the same height on Saturn. Okay. Now on Jupiter, your jump will be very small. On Mars, your jump will be very big. You can slam dunk that thing. Okay. So now here's a question. Can you even stand on Saturn? But can you stand on the surface of Saturn?
No, I don't think so.
Why not?
Because it's too windy and it's like slippery, I think.
That's not the reason. Anybody know why you cannot stand on Saturn? Why cannot?
It's the least dense and it's made out of gas.
Yes, you will sink. It's made out of gas. You will just sink.
Mr. Rachan, but what happens if we sink into Saturn and then we reach the core?
It will be very hot. Very hot. I think.
So we just sink to the core of Saturn if we go to Saturn?
Yes. Yes. I think the core is very hot. So let me Google that to see I like to know it too. So the core temperature of Jupiter. Okay. Oh my God. So for Jupiter, at the core is 24,000 Celsius. 24,000. Okay. Because it's so big. How about for Saturn? Hey, here's a fun fact. Jupiter is so big. Can you put all the planets in solar system inside Jupiter? Yes or no? Harry, you smart girl. Answer the question.
Yes.
Yes? Okay.
Yes.
So yeah, you can put all the planets in the solar system inside Jupiter. It's that big. Okay, core temperature of Saturn is 11,000 Celsius. Oh my God, 11,000 Celsius. And you guys complain that 30 Celsius is so hot. Okay. Every time I go to the classroom, somebody set the AC at 18 Celsius. Oh my God. So you're gonna die if you go to the core of a planet. Okay. Good job, Pat. All right. If no more questions on Saturn, we will go to the next presenter. Okay. So who's the next victim?
Me.
Okay. So the last person, Patter. Not Pat. So I want you to ask the next presenter. Okay. Come up with some questions for. Where are we now?
Me.
Ian. Okay. Come up with some questions. Pat. You're gonna ask Nian some questions.
Okay.
Okay. Go for it, Nian.
Okay. Do I present my screen?
Yes.
Can you see the presentation?
Yeah, very clearly. Very good.
Okay. Do I start now?
Yes.
Okay. So, quasars. First of all, what is a quasar? Quasar is a short term for quasi-stellar radio sources. Quasars are actually the active nucleuses of galaxies. Where is it? Astronomers think that quasars are located in galaxies which have supermassive black holes at their centers. How is a quasar formed? It is formed when materials passing by a supermassive black hole at the center of a galaxy get attracted to it, forming an accretion disk around it. Materials with very little velocity will fall into the black hole. When things get faster and faster as they fall into a black hole and bumping into each other more and more, that gravitational potential energy from things falling into the black hole is being turned into energy. Things start to get hotter as materials get nearer and nearer to the surface of the event horizon. Near the event horizon itself, things are so intense that it is releasing electromagnetic radiation across the spectrum, from X-rays all the way down to infrared. Some quasars can emit gamma rays or radio waves. Now some facts about quasars. Quasars are the most luminous object in our universe. It can be brighter than any galaxy, and that is just coming from a small material around a fairly small region of space. Studying quasars can help us understand the universe at its very beginning because supermassive black holes were formed shortly after the Big Bang. The Milky Way galaxy does not have an active nucleus or an active core. Therefore, it isn't a quasar. Therefore, there isn't a quasar in our galaxy. So our supermassive black hole at our center of the galaxy is not consuming matter. The closest quasar is 730 million light years away from us. We can only observe quasars at a certain distance away from us, and that distance is also a time in the past, because it took 730 million years to get to us. And when the quasar move closer in time to us, most of the materials have been consumed, and we are not observing quasars anymore, but galaxies. And the nearest active quasar is 1.7 billion light years away. Okay.
1.7 billion light years away.
Yes.
Okay. Leave the slide up.
Okay.
Okay. All right. Pat, ask him some questions.
Can anything develop from quasars after they die?
So what do they become after they die? How do they end up?
They become galaxies.
So quasar becomes galaxies.
Yes.
Okay. So the black hole just become normal matter, normal object after that, right?
Yes, because it has consumed all the matter it has.
Okay. Good. So that's something good to know also for everybody. Oh, good question. Any other questions for Nian?
How long does a quasar last?
What's the lifespan of a quasar? How many billion years? Okay, like the lifespan of the sun is 10 billion.
100 to 1,000 million years.
100 to 100,000?
No. 100 to 1,000.
100 to 1,000.
Million years.
Million years. Million years. M?
Yeah.
Million?
Yeah, million.
Oh, that's very short compared to the lifespan of the sun, our sun.
Yes.
Okay. Our sun already lived 5 billion years, and it's gonna live 5 billion more years. So,
But as long as but as long as there's matter for it to consume, it will probably last longer.
okay, okay. Now you say that the Milky Way has a black hole in the middle of the Milky Way, right, in the center. Okay. So, but that black hole is not considered a quasar. Why is that?
Yes, because it's not technically consuming matter, and so basically our black hole is technically inactive since it's not consuming matter, and therefore there isn't a quasar.
Okay. So, but let's say if it's consuming matter, okay, let's say our black hole is consuming matter. Is it big enough to become a quasar? You say it have to be a supermassive black hole, right?
Yeah.
That's what you wrote, supermassive. So is the black hole in the center of Milky Way a supermassive black hole or just a black hole?
It's just a normal black hole. And there's a theory that in 5 billion years, when Milky Way and Andromeda collide, the two black holes will the two black holes will, I don't know, something like form together and then
combine,
create a supermassive black hole.
Oh, okay. So
and
two
then
black holes combine and become supermassive.
Yeah, and then materials from Milky Way and Andromeda will be the fuel for the quasar.
I see. Now, what is coming out of the relativistic jet? The blue light that you that's in your picture there.
It's X-rays all the way down to infrared.
Oh, so it's just electromagnetic radiation.
Yes, but by the time we detect these things, the high frequency and the high frequency waves will become very low frequency waves like radio waves. So that's why it's called quasi-stellar radio sources.
Oh, is that because it's moving away from us?
Yeah.
Yeah, okay. So the universe is expanding. That's why all these objects are moving away from us. So that's why if it emits short wave, by the time it moves away from us, the short wave becomes long wave. It's like stretching the wave. So you guys remember the electromagnetic spectrum? So the short waves are the gamma ray and X-ray, and the long waves are the radio. Okay, long waves are radio. Okay, so the X-ray have been stretched to the radio. Good. See, that's why we learned the electromagnetic spectrum, so you guys can understand these things when you do your research.
Mr. Rachan, why do quasars emit radio waves? The electromagnetic thing. Why do
they emit X-ray? They emit X-ray, but because they're moving so far away, so fast from us, by the time the X-ray get to us, it has shifted to radio wave, to visible and then to radio, just like what he said in the slide.
Yeah. Okay.
Now, why does it emit X-ray in the first place? You have to ask Nian for that. So Nian, why does it emit any light and any electromagnetic radiation in the first place? Why does a supermassive black hole emits radiation? So why do you Google that? Why does a black hole emit radiation
right now?
So good question from
a central black hole, also called an active galactic nucleus, may grow by swallowing materials from the surrounding interstellar gas, releasing energy in the process. This leads to the creation of a quasar, emitting radiation that illuminates the gas present throughout the galaxy.
Okay, so it comes from consuming matter.
Yes.
Consuming matter, and then when it consumes matter, it crushes it with the gravity, and then it spits it out as radiation. Okay, it spits it out. So Mickey, so basically this black hole, remember black hole has the strongest gravity that we know in the universe. Okay, strongest gravity is inside black hole. So when matter falls into the black hole, they will be crushed. When they crush, that just like when you see two cars hit each other at high speed, right? If you see two cars crashing into each other at high speed, you're not just gonna have damaged cars after that. You're gonna have sound. You're gonna have light, right? There'll be spark. There'll be broken glasses. There'll be a lot of things. There'll be heat. When two cars hit each other, there'll be heat. So basically conservation of energy, right? So the energy from the two cars, from mechanical energy, from the kinetic energy, turn into light, heat, and sound. So just like this. So when black holes start eating up matter, then it just converts that matter into energy. What type of energy? In this case, is radiation. It's electromagnetic radiation, the X-ray. So, yeah.
Mr. Rachan, but the radiation does not come from the black hole. It comes from the material at the very edge of the event horizon. So if the material falls in the black hole, any radiation it might emit will not be able to escape. So
Okay.
it comes from the very edge of the event horizon.
Okay, at the edge, Oh, okay. So I guess that it's the material will, on the way down, it's gonna be some friction. It's gonna like evaporate. It's gonna be burned into pieces by the time it gets close to it. Okay. So okay. All right. What if it stops consuming matter? Would that relativistic jet stop? Nian? So if it stops consuming matter, just like our black hole in the center of Milky Way, so you don't have relativistic jet for that, right?
Yeah.
Okay. All right. So a normal black hole, so wouldn't have that. Wouldn't be like quasars.
Yeah.
Okay. All right. Okay, we done with that. Good job, Nian. Very interesting.
Yes.
All right. Very interesting. Okay. The next presenter is, who is it?
It's me.
Okay. All right.
We're not going to finish. It's already time.
Is it time?
It's time.
Yeah.
Hold on. 9:55. Oh yeah, it's time. So, TT, you have to wait until next time, and Nian is gonna ask you some questions next time. Okay. All right, guys. Just okay. Look at my video real quick. Okay, turn on the video. Okay. So work on this. Work on the worksheet, the Sun, Earth, Moon worksheet. Okay, that's your weekend homework. All right, and I'll see you guys next time. Goodbye, guys. Bye bye. Have a nice weekend.
Thank you, Mr. Rachan.
All right, see you, Mohan.
Bye bye, Lord Roshan. Thank you.
Thank you, Mr. Rachan.
And see you, Mickey.
I must wait until next Tuesday, right, Mr. Rachan, to do my.
Right. Sorry about that, but yeah, good discussion. Good discussion.
I've been preparing for it.
Okay, Potter, I'll send it to you again.
Okay. Bye bye.
Bye bye.